Well, good evening, class. This is your well-rounded math teacher, Mr. Picard. We're going to tackle Unit 11, Video 1, Arithmetic Sequences. Your learning target today is you can find common differences and the nth term of arithmetic sequences. A little bit about sequences here. Sequence is basically a list of numbers in a particular order. They have a sub 1, a sub 2, a sub 3 here. Those are your terms. A common sequence, not necessarily common, but one that is used in nature quite often, is the Fibonacci sequence, which is 1, 2, 3, 5, 8, 13. Excuse me. The key with the Fibonacci sequence is you take any term, take 5. 5 is the sum of the previous two terms. 2 plus 3 is 5. It always starts out 1, 1. So let's say 3. The previous two terms are 1 and 2. 1 plus 2 is 3. The Fibonacci sequence. We're going to be working with something a little bit different than the Fibonacci sequence today. That's arithmetic sequence. A sequence in which the term after the first is found by adding a constant called the common difference. The common difference is just D. If you look at this sequence over here, -8, -2, -4, -8, -6, -4, -2, 0, and so on and so forth. From one term to the next, it's 2 more. So we're adding 2 every time. So our common difference then is 2. In order to find the common difference, take a term and subtract the previous term from it. One that we'll be working on tomorrow is the geometric sequence. Geometric is a little bit different than arithmetic in the sense it's a sequence, but here it looks like we're adding 4 every time. But from 8 to 16 you're adding 8, adding 16. So we're not adding the same thing every time, so that's not an arithmetic sequence. We are multiplying by 2. And 8 to 16 you're multiplying by 2 again. So you're going to be working with what's called a common ratio. What are we multiplying by? In that case, we're multiplying by 2 every time. So we're going to work with the latter here. We're going to work with arithmetic sequences. It says find the next 4 terms in the arithmetic sequence. Usually take a term, I'll take like 43 and subtract the term before from it. 43 minus 49 is actually negative. It's -6. And you can have a common difference of -6. If you look at this, what's 55 plus -6? Well, it's 49. 49 plus -6 is 43. 43 plus -6 is 37. So basically you're adding a -6 or subtracting 6 every time. So we get 31, 25, and 19. So once again, my common difference here, D, would be -6. Okay. What do we got here? Okay. What is the common difference, D, of this arithmetic sequence? They're saying we're adding something every time. -1 to 6. Well, 6 minus -1 plus a positive, that's going to give me 7. 6 plus 7 is 13. 13 plus 7 is 20. So yeah, I'd say my common difference, I seem to be adding 7 every time here. There's a formula that's in the box in your notes. Finding the nth term of an arithmetic sequence. It has a sub n here, the nth term. If we had some sequence, I'll just say 1, 2, 3, 4, something simple like that. Okay, you're adding 1 every time. So my common difference is 1, and these are just the counting numbers. Let's say I want to find the 25th term. That means n would be 25 in this formula right here for finding the nth term. And you can say I'm finding a sub 25 if you wanted to. N is 25. We'll be talking about that in a few problems. Once again, D is your common difference. A sub 1 is your first term in the sequence. My first term here would be 1 in this case, but we'll look at another problem here. Okay, the table at the right shows typical costs for a construction company to rent a crane for 1, 2, 3, and 4 months. If the sequence continues, how much would it cost to rent a crane for 12 months? Okay, there's our little crane that we're going to rent. Here's our formula for the nth term. Now, they want us to go 12 months in. So the first thing I'm going to say is this. N is equal to 12. A sub 1, your first term. Well, our first term here in this case is 75,000. What else do we need to find? Well, we need to find our common difference. If we can find that, we can plug it into this formula for finding the nth term and solve it. I'll just pick any one here. I'll go with this one, 1,000, 105,000, and subtract the previous term, 90,000. If you plug that into your calculator, that's 15,000. And it does look like 75,000 plus 15,000 would be 90,000, so on and so forth. So our common difference is 15,000. So finding the, and you can write it like this, you can say finding a sub n, or you could say finding a sub 12, because we're finding the 12th term. So in this case, our n is equal to 12. But we'll just leave it as a sub n for right now. That's fine. A sub 1 is 75,000 plus n, which is 12 minus 1, and then times our 15,000 right here. Now you got to do a little bit of work, or you can just plug this whole thing right here into your calculator and you should get an answer. 75,000 plus 11 times 15,000. And altogether, all said and done, a sub n equals 240,000. 240,000. So the 12th month, if you're going to rent this crane for 12 months, it'd be 240,000. Write an equation for the nth term of an arithmetic sequence. There's a couple different ways you can do this. What I would do is see if you can find a sub n, or a sub 1. We don't know what n is, but we do know what d is, the common difference. And our formula is going to have n in it when you're all said and done. Our first term you can see is 8, so a sub 1 is 8. It looks like we're going up by 17 minus 8 is 9. 9 plus 17 is 26, so yeah, it looks like 9 is our d, our common difference. We don't know what n is, that's the question mark. So what it would look like if you want to find any nth term or any term in this for this sequence here, it'd be a sub n equals 8 plus n, we don't know, n minus 1, and our common difference is 9. So basically we're just going to clean this up and solve it for a sub n. It's going to equal 8 plus 9n minus 9. Finally, a sub n equals, it's 9n, well 8 plus negative 9 is going to give me negative 1. And there's our formula. Another way to look at this is as a linear equation. Y equals mx plus b, and you can do this also if you want. This actually looks like a linear equation right here, the way it's set up. And the way it goes is this. Your first term is 8, your second term is 17, your third term is 26. What you really want to find is the zero term, or your initial term. Here we got to work our way backwards. If we're subtracting 9 every time, 8 minus 9 would be negative 1. This is kind of like our y-intercept. Your slope is your common difference. You're going up by 9 every time here. So you could say y equals mx plus b. Well, your common difference, what you're going up by or down by every time, is 9, so that's 9x. And then if you can work your way back from 3, 2, 1 to 0 here, 0 is where your y-intercept occurs, so that's minus 1. So y equals 9x minus 1. So all these formulas and stuff we're working with here today are linear formulas, basically. Find the 42nd term of the sequence 8, 5, 15, 2. Well, looks like we're going up by 7s. So my common difference is 7. My first term, definitely 8. And n, well, they want us to find the 42nd term, so n is equal to 42. Plug it all in and solve. So a sub n, or you could say a sub 42 if you want to, because n is equal to 42. 8 plus n minus 1, so 42 minus 1 times our common difference of 7. 8 plus 41 times 7. So a sub n, our 42nd term, if you work it out, you should get 295. There you go. Here's another way of looking at it. Given a sub 1, they don't give us a sequence here, but they give you everything you need to know. A sub 1 is 13. Your common difference is 2, so basically you're adding negative 2 or subtracting 2 every time. They say find a sub 11. Some kids look at this and I'm like, well, I don't know what they want us to do here. A sub n is basically a sub 11. So n, you're just looking for the 11th term right here. So n's 11. D is negative 2 and a sub 1 is 13, so plug it in and solve. So we got 13 plus n's 11, because you want to find a sub 11, or the 11th term, minus 1. And our common difference is negative 2. Working it out, 13 plus 10 times negative 2, you should get negative 7 here. Yeah, negative 20 plus 13 is negative 7. A sub 11, or the 11th term. Okay, we're going to Hoopert Farm. Farmer Hoopert starts the hay season with 37 alfalfa bales in his barn. Each day he adds 40 alfalfa bales to the barn. Here's a little barn. There's some bales in there. Sweet. Whoops. Let's go back up here. Here's the formula we're going to be working with. First question is this. How many bales will he have in the barn at the end of the month? And we're going to say this is a 30-day month. Not 31, so we'll just say 30 days. So what does that mean? A couple things. First of all, n is equal to 30. He's adding 40 alfalfa bales every day, so our common difference is we're going to add 40. Now, a sub 1 here. A lot of people would say, hey, Picard, a sub 1 is 37. But we're going to talk about what's called the initial value. After the first day, he wouldn't have 37 bales in his barn. He would have added 40 to his barn after the first day. So really, if you're looking at it this way, a sub 1 would be 77. Let me put it like this. 77. So my a sub 1 isn't 37 in this case. What we're working with is if you start out with something before you even start adding anything to it, that's called an initial value, or a sub 0. A sub 0 is what we call an initial value. A sub 0 is initial value. That's my 37. So sometimes you start out with something and after the first year, after hour, after the first second or something like that, that would become your a sub 1. So sometimes you have to find your a sub 1 if you're given what we call an initial value. So a sub 1 in this case is 77, not the 37, like you would think it naturally. So we're going to go with a 30-day month here. So a sub n equals 77 is my a sub 1 plus 30 minus 1 times 40. 40 bales a day. It's a lot of hay. 77 plus 29 times 40. Multiplying the 29 times the 40 and adding the 77 to it is going to give me 1,237 bales. Right there. So after 30 days, you'd have 1,237 bales. If you just took 30 and multiplied it by 40, 30 days times 40 bales, that's 1,200 bales. He doesn't have 1,200 bales in a month. You have to add that 37 that he started out with. And that's how we come up with that answer, another way of looking at it. Sometimes it's just kind of common sense, but I wanted to show you this problem to talk about initial value a little bit. Sometimes you start out with a sub 0 instead of a sub 1. Okay. Hooper Farms here. Let's see what else they have in store for us here. Okay. How many days would it take Farmer Hooper to have a total of 1,757 bales in his barn? Okay. So here's the deal. This 1,757 is actually my a sub n. What I'm looking for is n. How many days does it take to get to that total? You can still use this formula right here, but we got to do a little bit of work for it. First of all, a sub n, like we said, is 1,757 equals a sub 1. We decided that 37 was a sub 0. Add 40 to that to get the first day's total at 77. That's a sub 1. Plus, we don't know what n is. N minus 1, and the common difference is 40. So if you look at this equation right here, the only thing we have for a variable is n. And n represents the number of days it's going to take to come up with these bales. So, we just need to solve it now. Okay, get this out of here. So we're going to use distributive property first. 1,757 equals 77 plus 40n minus 40. 1,757 equals the 77 and the negative 40 are going to add up to 37 plus 40n. Subtracting 37 from both sides. Oops. We are going to get 1,720 equals 40n. And finally, we just divide both sides by the 40. And n is equal to, sometimes you get a decimal. In this case, we got an exact answer, 43. N equals 43. So what does that mean? It means this. To get this total number of bales in the barn, so you can know a sub n and then solve for a sub 1, n, or d. In this case, we solved for n, the number of days, and that was 43 days. 43 days at Hooper Farms. Thank you, class. Peace out. Get busy on your worksheet.